Okay, this is for the Math 100 136 class, and this is just a few more word problems that will help you do your homework and hopefully just get some more practice in watching how to set up a word problem. So the first one is a bank loaned out $12,000, part of it at a rate of 6% per year and the rest at 16% per year. If the interest for the entire year, so 1 year, totaled $1,500, how much was loaned at the 6%? So anytime we're doing these interest rate ones, we're using right now simple interest, which was a formula I equals PRT. So we have two different types of accounts essentially though. So we earned some interest in the first account and some interest in the second account. So interest one is some unknown amount of this $12,000 went into an account. The rate for that was 0.06 and it sat there for a year. The other guy has to be whatever would be left out of the $12,000. So one way of writing that is 12,000 minus the amount we used in account 1. So that would be X. This one is at 16% and again sat there for 1 year. These two interests together should add up to $1,500. So if we write this out, this is 0.06x plus 0.16 times 12,000 minus x equals 1,500. All right, we need to distribute the 0.16 to that binomial. So 0.16 times 12,000 is 1,920. So this is 0.06x plus 1920. Distribute it to the negative x, that would be negative 0.16x equals our 1,500. Combine the like terms over here on the left, that'd be negative 0.10x. We can also subtract over the 1920. Which gives me negative 420. And I'm going to go ahead and divide that by the negative 0.10, which gives me 4,200. Now we need to put a unit with this because you always need to have units attached to your answers with word problems. This was the amount of money that was invested at the 6%. So this is $4,200 at the 6%. Now that is actually the only thing they asked me for in this problem. It just said how much did they loan at 6%. If we wanted the other piece as well, and you would have to read your directions to see what they want, you would just say 12,000 minus the 4,200 and that would give you your other amount. So it is critical to read what are they asking for. The second one I'm going to do is about the tea problem. It says the manager of a store specializes in selling teas and he decides to experiment with a new blend, or she, I guess. She will mix some Earl Grey tea that sells for $6 per pound with some orange Pioche tea that sells for $2 per pound to get 600 pounds of a new blend. She's going to sell the new blend for $5.50 per pound. And she wants there to be no difference in revenue from selling the new blend versus selling the other types. Now that's actually an important sentence that's going to help us set up, I can't really highlight the whole thing, but this right here is going to help us set up our equation. So what we're saying is that selling the Earl by itself plus selling the orange by itself should equal selling the blend. That's what she meant by C, no difference in selling the individuals versus the blend. So now we have to talk about what we know. Well, we're going to let the Earl Grey be X. I don't know how many pounds of the Earl Grey I'm going to put into the blend. So then we have 600 pounds for our desired final product. So 600 minus X could be how much we put into the orange, how much orange tea we put into the mix. Okay, so selling the Earl by itself would be $6 times the number of pounds of Earl. Selling the orange by itself would be $2 times how many orange pounds we're going to put into the blend. This is going to equal, now here's where this gets tricky. It is $5.50, but it's not just $5.50 for the whole blend. This is $5.50 for the total number of pounds we've made, so because it says per pound. So we have to multiply that by that 600 pounds. So this would be, let's do that, 5.5 times 600 is 3,300. And then we distribute over here, so this would be 1,200 minus 2x. Combine like terms, that's 4x. Subtract over the 1,200, and then we divide by the 4. So minus the 1,200 and divided, oops, I don't want that to be in mod. 2100 divided by 4, which is 525. So we need, that's for x, so 525 pounds of the Earl, and we will need 600 minus that, which is 75 pounds of the orange. And that's all there is to that. So that's very similar. This one's very similar to the mixture problems where we had the percent of acid or the percent of cement, except our percent isn't really here. It's the price per pound that we're looking at. Okay, and the final one that I'm going to do on this pre-video is about the work rate problems where you deliver newspapers but you both work at different times, and what we want to know is what would happen if you work together. Anytime you do a work rate problem, everybody needs to be working at a same unit of measure. So we always take the job divided by the time to figure out what happens in a single hour or minute. For us, it's going to be in minutes. So Trent does one full newspaper delivery per 10 minutes. So 1/10 of the job gets finished per minute. And Lois, it takes her 40 minutes to do this route, so she's 1/40th of the job gets finished per minute. What we want to know is if they combined forces, what would happen? How long would it take? So we call that unknown one 1 over unknown time. So anytime you're dealing with these, the two solo fractions will add together to equal the combo fraction. In this one, it actually, instead of clearing fractions for everything, it might be easier just to get a common denominator. So if I make that 4 over 40, I can then add my two fractions on the left together. That would be 5 over 40. And then this just becomes cross multiplication. So 5x equals 40, divide by 5, and we get 8 minutes. So if they worked together, they would get the whole newspaper route done in 8 minutes. Notice that's not much faster than what Trent's already doing, but Lois is not adding a great deal of work. She's taking 4 times as long to do the same job. So just having her do a few of the newspapers to help out is going to cut off 2 minutes of the time that Trent could have done it by himself. And that's it. I hope that was helpful, and hopefully you guys can finish your homework and feel a little bit more confident about word problems.